for the homework. Any problems that you all want to see work? If there's no questions on the homework, what we're looking at today is synthetic division. I do have all the steps written out. I went on and wrote those out and included those in the note sheet for you. So we're going to go on and work through each part of this here. All right, guys, let's focus in. So one of the first parts in steps 1 and 2 is the setup of the problem. So the problem itself, what we're going to be working on, we're going to draw a cubby, little backwards L, and a line. That's going to be the main part. That's where most of this work is going to be. Now to find the number and find what term is going to go in that cubby is we take what we're dividing the polynomial by, in this case m minus 3. We're going to set it equal to 0 and then get the variable with the biggest exponent by itself. In this case, that's just m. So we need to solve for m. And to solve for m, we're going to add 3 to both sides. negative 3 plus 3 is 0, telling us m is 3. Questions on this so far? Now we take the coefficients, or the number that that's equal to, and put those in the cubby. In this case, it's just 3. If we had a number and a variable with the number in front of it, we just take the coefficients. We take the numbers in front of them. So it's just 3 in this case. Is going to go in that cubby. Now the numbers that are going to go across the top, we're going to take the coefficients of what we're dividing, what's being divided, and list them out. If there's one missing, we fill it in as 0. So the number in front of m cubed is 1. The number in front of m squared is negative 13. The number in front of m is 24. And our constant term is 18. Now, since the polynomial that's being divided is a degree 3, we should have one more term than the degree written out. So there should be 4. Because we should have our m cubed, m squared, m, and constant. So there should be 4 numbers up there. It's just to check and make sure we have them all. 1, negative 13, 24, 18, we do have 4 numbers up there. Questions on the setup so far? We have one last part of the setup before we start dividing. The last part of the setup is we take whatever the first number is and drop it below the line. Okay, are you ready for the first part of this here? I am going to be drawing lines of where the scratch work and everything is going together. I would advise you not to do that because you can if you want to. There's just going to be a lot of lines going over the top of each other. Okay? Because our first main step is we're going to take the number in the cubby and multiply it by the number below the line. So that's going to be 3 times 1, which is 3. Okay? And once we do that product, we're going to put the result above the line and below the next number. Okay? Then our next step is we're going to add straight down. So we're going to take negative 13 and add 3 to it. And negative 13 plus 3 is negative 10. And we take that negative 10, nope, wrong spot, and we're going to put it under the line right underneath it. Negative 13 plus 3 is negative 10, so it drops below the line. Questions on this so far? Now what we're going to do next is essentially the same process. We're going to take the 3, bless you, and multiply it by the number below the line, which is our negative 10. And 3 times negative 10 is negative 30. And we take that negative 30 and put it above the line below our next number. And then we're going to add straight down. So we're going to have 24 plus negative 30. And 24 plus negative 30 is negative 6. And we put it below the line. Questions on this here before we do the next step? Then we're going to do what? We're going to multiply again. So now we're going to have, let's scroll down for a second, 3 times negative 6, which is negative 18. Which goes above the line and below our next number. And lastly, we're going to add 18 and negative 18 and get 0. And put it back here. So again, this is kind of why I said for the most part I wouldn't draw all these lines, because we do have a lot of things going different places. Now for the most part, if doing the scratch work on the side helps and seeing that helps, do that. I have a feeling for the most part you're going to just grab a calculator and have it do most of the multiplication adding as you go step by step. Questions on this here before we finish this up? Because we do have one last thing we need to do. We feel good with this here. Yes? Okay. I'm just moving most of those arrows out of the way so we can look at what's under the line. Now, the degree of what we divided this by, our m minus 3 is a degree 1, because the biggest exponent attached to the variable is 1, so it's a degree 1. Our remainder is going to be 1 less than that degree of what we're dividing by, so degree 0. It's just a number. Since we're dividing by 2 terms, our remainder should have 1 term. And the last number, in this case, since it's only 1, the last number below the line is our remainder. If it was, say, a degree 2 is what we're dividing it by, the remainder should be a degree 1, so we should have a variable and a number. So we should have 2 terms. So the last 2 numbers would be the remainder if we divided by a quadratic, an x squared. But here, since it's just a single 1 degree, we have 1 remainder. And inside that remainder is going to be our constant term, our term without a variable. Now we're going to move to the other numbers. The number after in front of to the left of the remainder is going to be our variable, or our term without a variable. We could say it'd be the variable to the 0 degree, but we don't write, and we would not write m to the 0, because anything to the 0 power is 1, really just telling us we have negative 6 times 1. The number in front of it, our 10, would be m to the first power. And then our 1 would be m to the second, because all we're doing is just increasing the degree by 1. No variable, m to the first, m squared. If there was a number after the 1, it'd be m to the third, m to the fourth, m to the fifth. We just keep going up by 1. And what that tells us from this part here, that our solution is m squared minus 10m minus 6, and then we would add our remainder to it. But since the remainder is 0, there is no remainder, telling me that the solution is just m squared minus 10m minus 6. And that's it. Questions on this here? We ready for the next one? Yes? All right. All right. So we are setting this problem up. One thing we'll need to do is solve for our v plus 4. We need to solve for the v. And to solve for v, we would minus 4. So those would cancel, telling us v is equal to negative 4. And the negative 4 would go in our cubby. We good with this so far? Now we need to list the numbers across the top, yes? So our v to the 5th is our biggest term, and its coefficient is 8. So we get 8 for v to the 5th. We get 32 for our v to the 4th. Then our v to the 3rd term would be 0. Since we don't have a v to the 3rd power listed, it has to be 0. V squared is also 0. Now v to the 1st, or v we do have, it would be 5, and then we would have 20. Because the number of numbers we need across the top of that line is one more than the degree. Since the degree is 5, we need 6 terms. So we have 8, 32, then we have 2 zeros, 5, and 20, so we now have 6. So we have to put those zeros back in for v cubed and v squared. Then, once we have it set up, we drop the 8. And now we can start the process with multiplying and adding. So the first thing we want to do is multiply the number inside the cubby with the number below the line. So we would say negative 4 times 8. And negative 4 times 8 is negative 32. And we put it above the line below the next number in the list. And once we put it there, we will add these two here. So we're going to say 32 plus negative 32 is 0. Yes? I'm not going to write this multiplication out, because what are we going to do next? We're going to do negative 4 times 0. And well, negative 4 times 0 is 0. Well, the next thing we need to do is we need to add 0 plus 0 is 0. Then we're going to multiply. Negative 4 times 0 is, well, 0. Then we need to add straight down. 0 plus 0 is 0. Now we're going to multiply again. Negative 4 times 0 is 0. And then we will add straight down. 5 plus 0 is 5. And lastly, negative 4 times 5 is negative 20. And 20 plus negative 20 is 0. I think we're starting to get the hang of how this works, yes? And for the most part, in all this here, we can do pretty much all this on the calculator. We can't type the whole thing in. but I can type in -4 times 8, as I'll walk you through this here. Because we would have said -4 times 8 is 32. And we have to add the next number in the line to it, which was 32, yes? Which gave us, then our next step was to multiply that value by -4, put it on top and add it to it, which was adding 0. Then we multiplied by -4 and got 0, added 0. So then we would multiply by -4 again, and then now add 5 to it, times -4, and then lastly add 20. So that multiplication addition, we can do most all that in the calculator. It'll do it for us. Questions on this here? So what do we need to do last? We need to put the variables back in. Now, because the degree of what we're dividing is 1, we should only have really one term, one number in our remainder, and that is the last number below the line. Then outside, the first number is going to be our term without a variable. It's our constant term. The one in front of that is going to be v to the first. Next, it's v squared, v cubed, and lastly, we have v to the. So if we want to rewrite this answer, our first term is going to be 8v to the fourth. Realistically, what is 0v cubed? 0, yes? Do we have any reason to rewrite it as 0v cubed? No. How about 0v squared? No. So really the next term that we have is our plus 5. So the solution for this here is 8v to the fourth plus 5. And that's it. Questions on this here? Do we feel comfortable with this here? We'll do one more. And then we'll cover, actually 2 more. We'll do this one and one more. Because I forgot about this one for a second there. But we're going to do 2 more, then cover the other problem that we have, or type of problem that we're going to talk about. Now this one here is a little bit different. And the main reason that it's different is that if we notice that the number in front of the variable that we're dividing by actually has a number. We actually have 3x. Yes? So if we did the setup, we find the number in the cubby, we put the numbers across the top. We have 3, -4 going on. You don't have to write this yet. Because our first step is to drop that 3 down, we would get 3. Okay. That's neither here nor there, telling us that the first coefficient is going to be 3 for our answer. Okay, I'm going to erase all this. If I did this in long division, we'd have 3x minus 1 on the outside. Inside, we have 3x to the third minus 4x squared minus, we have our terms inside, yes? So you don't have to write this down. But our first step for long division is we took the biggest term inside and divided it by the biggest term outside. Now our x cubed divided by x is going to be x squared. We agree with that there, yes? But we have 3 over 3. 3 divided by 3 is 1. But based on the way that it's set up, especially with synthetic division, that first number that dropped down would have been 3, not 1, yes? So here's the thing with synthetic division. If the number in front of the variable with the biggest power that we're dividing it by is a number other than 1, we have to divide the entire thing by that number. So since we have a 3 in front of this x, we have to divide both of those by 3. And we actually have to divide everything, every part of this problem by 3, because there's a 3 in front of that x. Specifically, in that divisor, if the number in front of the variable with the biggest exponent has a number other than 1, we have to divide the whole thing by it. Now, if it had been x squared plus 3x plus 1, that's fine, because the number in front of x squared is 1. But since 3x is the biggest, or our largest variable, or the big variable with the biggest exponent, we have to get it to be 1. Which means now that I have x minus 1/3, because 3x divided by 3 is x, 1 divided by 3 is 1/3. Now our first, the other set of parentheses, 3x cubed divided by 3 is x cubed. Unfortunately, our x squared next term, -4 and -17, don't divide by 3 nicely. And realistically, 4/3 and -17/3 are not nice decimals. We're going to leave them as fractions. So because there was a number in front of x, we've got to divide everything by that number. If it had just been x plus 3, we're fine. But because it's 3x, we got to get rid of that 3 in front of the x. Now everything else holds, is the exact same. Yes. X minus 1/3 is equal to 0. We set it equal to 0, solve for x. And we're going to put that number in the cubby. Numbers going across the top, we'd have 1, -4/3, -17/3, 2. And we bring the first number down. Now does that first number match up to what we would have with long division, with what it should be? Yeah. That's the issue, is because of that, 3x and the 3x cubed aren't going to line up. It's going to give us the wrong thing. Are you ready to start the synthetic division? This looks like it's not going to be fun. Well, the first multiplication is kind of nice. 1/3 times 1 is 1/3. If we don't want to do fractions, we can say 1 times 1/3 is 1/3. Yes? All right. Let's come back over here. Now we're going to need to add straight down. We need to add -4/3 to 1/3. Luckily in the calculator, I can just say plus -4/3. So it's going to take the previous answer 1/3 and add -4/3 to it and tell us that it is -1. All right. Now we're going to do it again. 1/3 times -1. So we're going to multiply by 1/3, and it's going to tell us it is -1/3. And again, we're going to need to add. So we're going to add to it -17/3, which is -6. Then we're going to multiply by 1/3 again. Because 1/3 times -6 is -2. And last but not least, 2 plus -2 is 0. We don't have any numbers left on top, so we're done. Since we divided by a degree 1, only the last number under the line is the remainder. Our numbers next to it, the -6 would be our constant term. The -1 next would be our x, and then our 1 would be x squared. Telling us that our answer is x squared minus x minus 6. Questions on this here? That probably wasn't your question, but yep. Anything divided by itself is 1. So even though it's 5x, negative 5x over 5x, the 5x and 5x would give us 1. Then we'd have the negative. Yep. Questions on this here? Do we feel comfortable with this? Now, if you've noticed, every single problem we've had up to this point has had a remainder of 0. So the reason I was saying I'm going to do 2 more, I do want to do at least 1 where we do have a remainder other than 0. No, it's just worked out that the remainder, the question is the remainder have to be 0? No. The remainder does not have to be 0. It's just worked out that the remainder on these is 0. And interestingly enough, the way we write the remainder for synthetic division isn't any different than long division. Now, just like the last one, the first thing we'll want to do is solve for the x and get negative 1. Now, because the number in front of our x with the x plus 1 is 1, I don't have to divide the whole thing. We're good with that there, unlike the last problem. Now, the numbers across the top, we'd have 3 for x cubed, negative 2 for x squared, 2 for x, and negative 5. And we'll bring down the 3. I'm not going to do a lot of the extra addition, multiplication steps on the side, the scratch work. If that helps you, having that written out and having that there, write it out. Do that. If, like on the last one where we did pretty much all of it in the calculator, right along with it, do that. If that helps, do that. If not, you don't have to. Because at this point here, we're going to have negative 1 times 3 is negative 3. Then we add straight down. Negative 2 plus negative 3 is negative 5. Negative 1 times negative 5 is positive 5. 2 plus 5 is 7. Negative 1 times 7 is negative 7. And lastly, negative 5 plus negative 7 is negative 12. Now, since what we're dividing this by is a degree 1, we should only have 1 term in our remainder, our constant term. And when we put the variables back, 7 would be the term without a variable. 5 is going to have, well, negative 5 is going to have x. 3 is going to have x squared. So the whole part of our answer, the part that divided evenly, is going to be 3x squared minus 5x plus 7. Now our remainder, we're going to add a fraction and we're going to put the remainder on top. This should seem very similar to what we did with long division. And what we're going to put on bottom is what we divided by. And that's not negative 1. Because what are we actually dividing by? We're dividing this by what? X plus 1. We're actually dividing that polynomial by x plus 1. All the steps in this entire setup, and what we're doing is synthetic division. It's an easier way to do it instead of long division. We're still dividing by x plus 1, but we're using this setup to make it nicer. So we still have to put x plus 1 underneath. Questions on this here? So I think we feel comfortable just here. Yes? Okay. We're going to come back to this one, but I want to skip ahead to this problem here. evaluating a polynomial. So we want to use synthetic division to evaluate this polynomial when x is equal to -4. So really what this is telling us to do is use synthetic division with -4. Because our first step in synthetic division is to take the term that we're dividing it by. So in this case, they would have told us divide this by x plus 4. First thing we did was get x by itself, and then plug that number into the cubby hole, the cubby. Well, they already told us what it is. X equals -4, so we can stick the -4 in the cubby. Numbers going across the top would be 5 for x cubed, -1 for x squared, 13 for x, and then 29. All right. We ready to do the synthetic division? Yeah, we skipped quite a few. Keep going. Almost. There we go. -4 times 5 is -20. -1 plus -20 is -21. -4 times -21. The negative and negative make a positive, so we're really looking at 4 times 21, which is 84. We're going to add straight down. 13 plus 84 is going to be 97. And 97 times -4, 8 carried with 2, 36, -388. And then we're going to add straight down. 29 plus -388 should be -359. Okay. So that's our synthetic division. We're going to stop there for now. I'm going to put a line. Because this example problem, it says evaluate a polynomial. Well, up to this point, the way we evaluated a polynomial is I took whatever the value they told me x was, and just plugged it in, yes? So when we evaluated, we replaced every x with whatever the value they gave us. Oh, no. It might help if I'm also on the right page. So all I did was just type -4 in place of x in each of those spots. So we're just doing our evaluating, yes? And the calculator tells me that it's -359. So when I evaluate it for -4, I replace every x in the function with -4. We get -359. What's interesting about that? It's the same as the remainder, isn't it? This isn't on your notes, but the remainder theorem states if a polynomial f of x is divided by a binomial k, x minus k, then the remainder r is equal to f of k. So if we take whatever that value is, we essentially solve it, we flip the sign. We take that value k and plug it in, that value will be the same as the remainder. That's kind of nice. But also, let's think back to chapter 3. When we were solving, especially by graphing, we were trying to find the values of x that make the function equal 0. So that tells me if the remainder is 0, whatever that value, in this case of k is, will be a solution. It also gets us a way to decrease the degree of the equation by 1. Because if you notice, each time we've done it today, it's taken the degree down by 1, yes? So that's, both of those pieces are nice because it's giving us ways to decrease the degree of a polynomial equation by 1. And we'll be using that. But for now, if I want to evaluate this function when f is 5, x is equal to 5, with synthetic division, we'll set it up. We'll put 5 in the cubby. We'll put the numbers across the top as 4, negative 10, negative 21. And we'll drop the first number. We're going to multiply 5 times 4 is 20. Negative 10 plus 20 is 10. 5 times 10 is 50. And lastly, negative 21 plus 50 is 29. So that tells us that f of 5 is 29. That the value, when we evaluate this when x is 5, its value is 29. Questions on evaluating these here? Do you feel good with synthetic division and evaluating? Yes? Any questions on this here? Okay. I want to go back to this one here. I'm going to probably run over the bell, and whoever you have next, you can blame it on me if you want to stay and finish and see this. Because it is possible to divide using synthetic division when we're dividing by a term that is a trinomial, has a degree of 2 or greater. It is still possible. But the setup and the way we do this is a little different. One thing, we're going to have 2 lines instead of 1. And also the x squared, what we're dividing by, we're not going to get just x by itself. We actually get x squared by itself. We have to get the variable with the biggest power by itself. So to do that, the first thing we're going to do is add 4, giving us x squared minus x is equal to 4. But we'll also need to add x, minus x squared is equal to x plus 4. So we have to get the variable with the biggest exponent by itself. So we need to get x squared by itself. Now we're going to take the number in front of x and put it in the cubby. We're also going to take the constant term and put it in the cubby. That's not 14, it's 1 and 4. We have 2 different numbers. 1 is taking and is representing the x value, 4 is representing the constant number. Now the numbers across the top is going to still be the same as before. 2 for x to the 5th, 1 for x to the 4th, negative 15 for x cubed, negative 2 for x squared, 10 for x, and negative 24. Same as before, yes? Next step is kind of the same. We are going to bring the 2 down. So thank you. So the 2 is going to go all the way to the bottom, because since we do have 2 terms inside the cubby hole, we have 2 lines. If we had 3 numbers inside the cubby for a cubic, we'd have 3 lines, and that first one would go all the way down. The next number is going to go down 1 less than the first, and then we would keep going until we've solved that out. So here the first one goes down 2, second one goes down 1. Now we're going to start this multiplication process, and they all multiply with the bottom number. So we're going to do 1 times 2, which is 2. And all the numbers that are multiplying with that 1, that x term in the cubby, is going to go above that second line. 4 is also going to multiply with this 2. 4 times 2 is 8. And that constant term numbers multiplication is going to go above that second line. I don't think it's going to be on the homework, but I do find it's nice to know that we can do this. So that's what I'm kind of working through with y'all. Now the next step is just adding. 2 plus 1 is 3. Negative 15 plus 8 is negative 7. Yeah, I will have the rest of it up there, so if you want to come back and watch it, you can. Because then we're going to do the multiplication again.
Yeah, that's what I
1
figured.
times 3. Yep,
Yeah,
is 3. 4 times this 3 down here is going to be 12. And then we would, yes. So a lot of this here they don't really teach, not necessarily teach it because it's overly difficult. There's just a lot going on. Because then it's still just 1 times our negative 4 down here, which is going to be negative 4. Then our 4 times negative 4 is negative 16. Make sense? Kind of. Then we would add 10 plus negative 4 would be 6. 10 plus negative 16 would be negative 6. So we do it one more time. 1 times 6 is 6. 4 times 6 is 24. We add one last time. Negative 6 plus 6 is negative 24 plus 24 is 0. Yes? Do I have any more numbers we can work with on the top? No. So we're done. Then we drop that down. Now the degree of what we're dividing by this time is 2. So the degree of the remainder has to be 1. So we're going to have 2 terms. Yes? So these last 2 are the remainder. Because the degree is 1. Now we put the variables back in. Inside the remainder, term without a variable, variable with the first. So we would have 2 parts of the remainder. Outside, no variable, variable to the first, variable squared, variable.
How do you know what to do
So the variable,
like, for example, whenever you're putting it at the end as your, answer, how do you know if it's plus or minus? Is it because it's not negative?
if it's not negative, it's understood to be positive. So we put a plus. Does that make sense? So that's it. So it is possible to do it with these higher degree.